Hello guys, in previously we had studied about the semantic nets. See, and today we're going to start our next topic, that is the frames. The idea of semantic net was started out simply as a way to represent labeled connections among entities. So, as we expand the range of problem solving tasks that the representation must support, the representation itself necessarily begin to become more complex. In particular, it becomes useful to assign more structure to node as well as to the link. Okay, there is no clear distinction between the semantic net and the frame system, but the more structures the system has, the more likely is to be termed as the frame system. Means the more structure the system has, the more likely it is to be the termed as the frame system. Means the frame system is more structured than the semantic net. Okay, now what actually the frames is? Okay, frame is a collection of attributes, usually or generally called as the slots, and associated values that describe some entity in the world. Okay, sometimes a frame describes an entity in some absolute sense, that is, sometimes it represents the entity from a particular point of view in which the term in the particular now we'll see what actually the frame is. Okay, a frame is a collection of attributes, generally called as the slots, and the associated values, okay, that describe some entity in the world. Sometimes a frame describes an entity in some absolute sense, but sometimes it represents the entity from a particular point of view. Okay, a single frame taken alone is rarely useful. Means we have, when we consider the frame system, just a single frame is not as much useful. That's why we have to build a frame system instead of using a single frame. Okay, out of from which we can build the system out of the collection of frames that are connected to the each other by virtue of the fact that the value of an attribute of one frame may be another frame. Okay, see, the frame system can be used to encode knowledge and support reasoning. Okay, when we talk about the frame system, generally the set theory, you all had studied in the previous standard, that set theory provides a good basis for understanding the frame system. Okay, in this view, each frame represent either a class, we can call it as a set, or an instance, that are the element of a class. Okay, see, here are the two figures, that is figure A and the figure B. In this example, the figure A, in the figure A, the frame person, comma adult male, comma baseball player. See, when we talk about the frame system, set theory provides a good basis for understanding the frame system. Okay, in this view, each frame represent either a class, we can call it as a set, or an instance, that is the element of the class. To see how this work, consider the frame system that is shown in the figure B, which is slightly modified form of the network shown in the figure A. In this example, the frame person, adult male, baseball player, pitcher and ML baseball team are all classes. The frame PV Rees and Brooklyn Dodgers are the instances. Okay. In our previous lecture, we had talked about the conversion of unary and ternary predicates into binary. So when we had studied about the unary predicates, there are two relations we had used to convert them, to convert the unary predicates into binary one. The relation we had used there are two types. The first one was is a relation and the second was the instance relation. Okay, the is a relation that we have been using without a precise definition is in fact the subset relation. Okay, the set of adult male is a subset of the set of people. The set of major league baseball player is a subset of the set of adult male, and so on. Okay, our instance relation corresponds to the relation elements of. Then PV Rees is an element of the set of fielder. Okay, thus it is also an element of all the superset of fielders, including a major league baseball player and the people. Okay, this is the this is the frame implementation of figure A shown in the figure B. Okay, when we represent a class as a set, there are two kinds of attributes that can be associated with it. Okay, that are the attributes about the set itself, and the second one, the attributes that are to be inherited by each element of the set. Okay, see here in this figure B, we indicate the difference between these two kinds of attribute by prefixing the letter with an symbol asterisk. For example, consider the class ML baseball player. We had shown only two properties of it as a set. Okay, that is, it is a subset of the set adult male and it has the cardinality, that is 624. This means that there are 64 major league baseball player. Okay, and again there are 5 properties that all major league baseball player have, which are that the height, bats, batting average, team and uniform color. Okay, and we have specified the default values of first 3 of them. Okay, by providing both kind of slots, we allow a class both to define a set of object and to describe the prototypical object of the set. Okay, sometimes the distinction between a set and individual instance may not seem clear. For example, the team Brooklyn Dodger, which we have described as an instance of the class of Major League Baseball team, could be thought of as a set of players. Okay, suppose instead that we want to represent the Dodgers as a class instead of an instance, then its instance would be the individual player. It cannot stay where it is a hierarchy. It cannot be a subclass of ML baseball team, because if it were, then its element, namely the player, would also be the would also by transitivity of a subclass be the element of the ML baseball team. Okay, which is not what we want to say. So we have to put it somewhere else in is a hierarchy. Again, consider the second example. We could make it a subclass of Major League Baseball player. Then its element, the players, are also the element of baseball player, comma, adult male and the person. Okay, means it becomes the element of all three classes, that is ML baseball player, adult male and the person. That is acceptable, but if we do that, we lose the ability to inherit the properties of Dodgers from general information about the baseball team. Okay, we can but we can still inherit the attributes for the elements of the team, but we cannot inherit the properties of the team as a whole, that is of the set of player. Because consider the another scenario, we might like to know what is the default size of the team is, that it has manager and so on. Okay, the easiest way to allow for this is to again revising our idea of the Dodgers as an instance of ML baseball team with the set of player given us as a slot value. Okay, again we are having the more general problem that a class is a set, and we want to be able to talk about the properties that its element possess. We want to use inheritance to infer those properties from general knowledge about the set, but a class is an also entity in itself. It may possess properties that belong not to the individual instance but rather to the class as a whole. In case of Brooklyn Dodger, such properties included team size and existence of manager. We may even want to inherit some of these properties from a more general kind of set. For example, the Dodgers can inherit a default team size from the set of all Major League Baseball teams. So, to support this, we need to view a class as two things simultaneously. That is, a subset in bracket is a of a larger class that also contains its element and the instance of a class of a set from which it inherits its set level properties. Okay, when we talk about the classes, generally there are two kinds of classes. To make the distinction clear, it is useful to distinguish between the regular classes whose elements are individual entities, and the second kind, that is the meta classes, which are special classes whose elements are themselves classes. Okay, means a class is now an element of instance. A class is now an element of some another class, or maybe many of the classes, as well as a subclass of one or more classes. A class inherits properties from the class of which it is an instance, just as any instance does. In addition, a class passes inheritable properties down from the superclasses to its instances. See in the figure, it shows the classes and the meta classes. Okay, see, every class is a set, but not every set should be described as a class. A class describes a set of entities that share significant properties. In particular, the default information associated with the class can be used as the basis for inferring values for the properties of its individual element. So, there is an advantage to representing as a class those set for which membership serves as a basis for non-monotonic inheritance. Typically, these are sets in which membership is not highly ephemeral. Instead, the membership is based on some fundamental, structural, or functional properties. Okay, to understand this, consider the three sets given here. The set 1 is just a people. The set 2, the people who are Major League Baseball player, and the set 3, people who are on my plane to New York. In this, the first two set are representing a classes in which a substantial number of inheritable attributes can be associated. Okay, we can inherit as many as properties from these two classes, but in the last set, which is different from the above two classes, the only properties that all the element of the set of that set probably share are the definition of the set itself and some other properties that follow from the definition. Okay, so a simple set with some associated assertion is adequate to represent all these facts. Okay, this is all about the frames. Thank you.